So section 3.3, more solving of equations, solving for x or whatever. But let's see what we can kind of show you, little tricks of the trade when equations are involving fractions. So hopefully this little, if I remember this handout correctly, a little bit of like a step-by-step investigation, not so much, example after example after example. So hopefully you can kind of follow along with where this is kind of going and what it's kind of building up to. So let's dive right in. So consider problem number 1 below. I don't know if that's like necessarily below, but whatever. So consider this problem. X over 4, or x divided by 4, equals 5 divided by 2. What could we do to get x by itself? Well, couldn't we just, if you're kind of going with what you, like the basics of getting x all by itself, wouldn't you just have to multiply both sides by 4? If this says x divided by 4, then wouldn't we just need to multiply 4 over to the other side and be done with it? Yeah, that's actually true. But again, we're building to something a little bit more general or universal as a trick. So let's keep going with this. Could we also, in theory, multiply both sides by 2? Because look over here. This says 5 divided by 2. If we multiply 2 to both sides, wouldn't this just turn into like a 5? And then the 2 would end up over on the other side? Yeah. Yes, but then we'd end up with like a 2x over here, So the 4 would get multiplied over here to the 5, and the 2 would get multiplied over here to the x, right? But then eventually by the end of it, to get x all by itself at the end of it, we would need to then divide both sides by 2 to finish getting x by itself. Which would end up being like 5 times 4 and then divided by 2. So now consider this problem. What could we do to get x by itself? This one's a little bit different because x is in the denominator. So this doesn't say x divided by 9. This says 9 divided by x. It's different. You can't just like multiply both sides by 9 to get x all alone. That's not how this one works. So here we would have to like multiply both sides by x. Like we'd have to move the x over here, like multiply it, and then divide both sides by essentially 3/7, because we would have like 3/7 times x equals 9. So then we have to, to finish getting x by itself, we would then divide both sides by 3/7. To avoid dividing both sides by a fraction, again, just like we talked about up here, as we're multiplying both sides by x to kind of move this denominator over here, couldn't we multiply both sides by 7, like kind of at the same time? Yeah. To get to the point, when an entire equation is simply made up of one fraction equal to one fraction, just like this, fraction equals fraction, one fraction equals one fraction. When your equation is essentially that, we call it a proportion, or we can call it a proportion. And to make the equation easier to work with, a very common first move is to cross multiply. So maybe you've heard about this before. So if this dragged out like step-by-step analysis, really breaking it down approach, if that confused you at all this really was about was what you might have already heard of before, which is called cross multiplying. Okay? Like multiplying 2 to the x, but at the same time multiplying 4 to the 5. Might even be something in middle school that was called like butterfly. I don't want to be wrong about this, but It's possible that in middle school you kind of referred to this as like some kind of butterfly method or something. But anyway, let's kind of do some examples, right? So I think these are the very same examples that we just did, maybe. Well, maybe this is what it meant by consider problem number 1 below, because when we get down to this part, it was below. So, okay, that's what it meant. All right. So we're going to basically what's called cross multiply. When it's a fraction equal to another fraction, we basically do this like diagonal multiplying where x times 2 ends up on this side, and then 4 times 5 ends up on the other side. And now we have this that we can deal with, which is a lot easier. You know, no more fractions. Okay, so this is essentially multiplying both sides by 4, but at the same time multiplying both sides by 2. You know, so the 2, anyway. So then we just got to divide both sides by 2 and get final answer. Same thing here. We cross multiply to where we have like 3 times x and then 7 times 9 to kind of be put on opposite sides of an equal sign. So 3 times x, we're cross multiplying. That's why it's called that. And then we just got to what? To finish solving for x, divide both sides by 3. And that's what we can do. Number 3, I know it looks nastier, but isn't this technically one fraction equal to one fraction? So yeah, we can cross multiply. It's just that the 3 times 8, that's simple enough, but this one right here, 2 times this, you just got to keep in mind that it's not just 2 times n, it's 2 times the entire n plus 1, right? It's this entire denominator times the entire numerator up here. So to kind of write it out, you know, this is what we kind of have. 3 times 8 is 24. 2 times this, kind of like it's in a bubble. And basically what's going to end up happening is distributing it. So the 2 gets distributed, and we end up with 2n plus 2. So I guess this is the full result, the final result of the cross multiplying. And then again, now that we did that, we can proceed fresher with solving for n. So we subtract 2 from both sides, and then divide both sides by 2. Same old stuff we've been doing for weeks, if not months. Ooh, why is this? What kind of curveball is going to happen here? We have an x here and an x here. Well, okay, let's see what happens. It's still one fraction equal to one fraction, so we can cross multiply. So we're going to have like 4 times x on one side, 12 times x on the other. Okay, no big deal. So what is our training up until now? Kind of, what does it tell us to do? You know, we want to eventually get x all by itself, but only on one side. So don't we have an x on both sides, and we have to like move one of them. So remember, we like to move the smaller one, so we're going to subtract 4x from both sides. The right side, well, guess I didn't want to show that fast, maybe. But so the right side becomes 8x. The left side, this might be new to you, maybe. The left side is going to be 0. That's normal. That's not that weird. Okay, but so this is what happens. So we have 8x equals 0. What's next to like solve for x? Wouldn't we now just have to divide both sides by 8 to get this 8 out of there and have x be by itself? Okay, what's 0 divided by 8? 0. So we get a final answer of x equals 0. Not weird, like that can happen. Okay, so just more cross multiplying. Well, what do we do here? Cross multiply. Do we not have one fraction, even though it looks kind of ugly? It's still just one fraction on the one side and just one fraction on the other side. So we can do this cross multiplying move, or the butterfly move, if that's what middle school called it. So here we go. If we write it out nice, remember it's 3 times that entire 5x minus 20 on one side, and then 2 times the entire 6x minus 3. So the use of parentheses is valid here and necessary. So what do? Well, don't we now distribute to clear the parentheses? So 3 times 5x is 15x. 3 times negative 20, negative 60. 2 times 6x is 12x. 2 times negative 3, negative 6. So now you just regroup, look at this with fresh eyes and go, okay, so how do I proceed with this? Well, don't we want to get x is only on one side? So we do that. So the right side is now just going to be negative 6. And the left side is going to be now 3x with the minus 60. And then again, like now we look at it, regroup, refresh, and just proceed with now we're in the business of just getting x all by itself now that it's only on one side. So we add 60 to the other side, and then we divide both sides by 3, and we end up with x equals 18 for that one. Well, as always, pause the video if necessary. But here's the next one. Nothing too different and new. It's it's a cross-multiplying situation. Just one single fraction. One single fraction. I know it's ugly, but so let's talk this out here for just a second, just to make sure you're not confused. This hopefully is not weird at all based on our previous examples. 4 times the entire 6x plus 5. 8 times this. It's 8 times 3 times the bubble. It's not, I don't even know if I want to even say this out loud. You do not have to multiply 8 to the 3 and then also to that bubble. Remember, it's just like 3 things multiplied together. It's not a distributive property situation until the next step, But we can really just do 8 times the 3, and that's it. And then do 24 times the x plus 1 bubble, okay? So that's after the distributing. And now what? Don't we have to well, we can't have x on both sides. So maybe let's move that one over. But check this out. If your idea was to, let's move this over, but look what happens over here. 24x minus 24x. That also is like 0. So what you end up having is basically just the 20 equal to 24. So remember, making this video, I can't remember if this has come up before. It probably has. I would say, yeah, you should recognize this as, as I was trying to solve for x, it completely dropped out on both sides. And so what I ended up with is something that's either true or it's false. Now this is definitely false. 20 does not equal 24. These are not the same. So this is a false statement. So what's the conclusion when it's a false statement? No solution. No solution. Okay. Probably moving into maybe the second part of this lesson where things get a little bit juicier, maybe. Let's keep this going. Let's not lose our momentum. Consider the equations below. Are these proportions? Would you consider this equation or this equation as proportions? That's when it's one fraction equal to one fraction. Like the entire left side is just one fraction and the entire right side is just one fraction. Well, no. This is a fraction and then minus another fraction on the left side. So these are not proportions. Okay? So guess what? You cannot do the whole cross multiplying, you know, song and dance with these. So what are we going to do? Well, let's just cut to the chase. What we could do is we could do whatever needs to be done to combine these two fractions together, like literally do the subtraction, you know, you're going to make common denominators, but we could combine these into one fraction, you know, then do the cross multiplying. Or we could do this. Multiply both sides by whatever will clear all the fractions. In other words, like cancel all the denominators. I don't know, maybe you can sort of understand what that means. But those are the two methods. So as you finish writing that down, you know, again, the first approach would be like literally doing this subtraction, making common denominators to bring them together into one fraction. Same with this over here, or any example, like, you know, because once it was a proportion, you could then cross multiply, yada yada yada. Or since you're allowed to multiply both sides by whatever you want, as long as it's the same thing, you can pick something very carefully, you know, where whatever you're multiplying to both sides is a very special number that's going to cancel all the denominators you have just in one fell swoop, because after that, then you won't have any fractions to deal with, and you can just kind of solve it a whole lot easier. I tend to like this second one, the maroon method. But let's see what's going on here. I really wrote out the work here, like all the steps. So here, like, looks like I am doing that maroon approach, okay? So what did I do? I multiplied both sides by 6. Because if your denominators are 6 and 3 and 6, I mean, long story short, you're basically coming up with like a least common multiple, or really any common multiple. Any common multiple of all the denominators is going to clear all of them. I'm actually kind of surprised this step was written out like this, but it's very thorough, you know. But I don't think you need to like literally write out this step in the future, or like on a test or something. But essentially what we're doing is we're multiplying both sides by 6. Like, we're allowed to do that. And if you then distribute this 6 to this fraction, those are going to clear. And if you multiply 6 to this fraction, yeah, you can think of it as you're getting 24x, which is true. But I think when I was growing up with this, in my head, it was about how when you multiplied 6 to this fraction, the 6 and the 3 would cancel, but you'd be left over with a 2, and that would get multiplied to the 4x. I don't know, maybe this way is good. You know, then you just do the 24x divided by 3. Same thing over here. Like the 6's are basically going to cancel, and you're going to end up with 7. Okay, so hopefully this first example is not too rough. But once you do that, once you multiply both sides by whatever is going to clear all the denominators, again, it's like a common multiple, maybe hopefully a least common multiple of the 6 and the 3 and the 6. Eventually you end up with that, which is like, okay, now we're talking. I can solve that. X minus 8x, negative 7x. Solve for x. Bam. All right, hopefully these last couple examples will make more and more sense. So here we go. So we have all these fractions. We have a 4, a 5, and a 2. So what would be like a common multiple of all three of those? Because if we multiply both sides by that magic number, all these denominators are going to end up getting cleared out, like canceled out, and we won't have any fractions to worry about, from there on out. So can you think of like a number that would be like a common multiple of all three of those numbers? Would it be 10? No. That wouldn't work with that one. 15? No. I think it's going to be 20. So we're essentially going to be like multiplying that entire left side by 20, meaning like both fractions. And then the same. So again, the strategy here is that once we finish doing this multiplying, we're not going to have any fractions left over to worry about. So, and I didn't mention this yet, but keeping in mind that technically multiplying by 20 means multiplying by 20 over 1, okay? So we end up with this. And then 20 divided by 5 is 4. And then we can just solve. Okay. I think as you finish writing this out, maybe, like when I was your age growing up, I would have thought of this as, okay, 20 will cancel with the 4, but there'll be a 5 left over, because 20 divided by 4 is 5, and then that 5 gets multiplied to the x to basically be, I guess right here. Yeah, right here, 5, or, whichever, either one of these. And then when the 20 gets multiplied to this fraction, the 20 cancels with the 5, but there's still a 4 left over to get multiplied to the x minus 3, which needs distributed. And then over here, the 20 cancels with the 2, but there's still a 10 left over to get multiplied to that 3, which is where the 30 comes from. One more problem. So we have these fractions. And so what would we multiply by to both sides that would clear both the 6 and the 4? Well, 24 would be fine, but I think if we just multiply both sides by 12, 12 would be more of a least common multiple. So again, this 12 is going to get multiplied to the 2x. This 12 is going to get multiplied to the negative 1. And this 12 is going to get multiplied to this fraction. And it's going to cancel with the 4. That's what we want. Over here, the 12 is going to get multiplied to this fraction. And focusing on how the 6 is going to get canceled out with the 12. Because again, technically, it's 12 over 1. That's getting multiplied to all this stuff. So let's see what my work looks like here. Like really writing it out. Like the 12 times the 5 to make 60. 12 times 2 is 24. 24x. 12 times negative 1 is negative 12. 12 times that entire x plus 3. Okay? But then on the next step, now we can worry about how 12 divided by 4 is just 3. So 12 divided by 4 is 3. 60 divided by 6 is 10. And then from there we would distribute, yada, yada, yada. Now, see, once we clear the fractions, now you're just solving for x however you need to solve for x. So clear the parentheses, and then, man, look at all these like terms that we can combine that are already on the same side. And then we got to get x only on one side. And then from there we just got to get x all by itself. Okay? So again, kind of looking back at this, it's if your equation involving fractions is literally a proportion, you can cross multiply to kind of get the ball rolling. If it's not a proportion and it involves fractions, you can do this trick of multiplying both sides by some least common multiple of the denominators to clear all the fractions, and then kind of go from there. Alright, so that does it for this section 3.3.